to Dr. Go. This is our group member from right, Noraida, Nurlani, me, myself, Nazrul Zairi, Nino Afzan, and Muhammad Ashdad. This is our presentation about our subject, Integrated Design Project. And
in this project, we are required to calculate OTTV and RTTV, design lightning, design green parking, renewable energy, and rainwater harvesting.
Hi, and good evening to Dr. Go. My name is Nazrul Zairi bin Kifli. Now I'm going to present part of OTTV and RTTV. This is the graphic of the building, graphic picture, graphic illustration, and this one is the real one. So next slide is, so the first calculation that I've done is heat conduction through wall. This is the table from the AutoCAD. I got area for the southeast, which is the elevation of the building, is for the facade area 13,326, and for the window area is 7,456. For the southwest, which is the right side of the building, 11,384, and for the window area is 3,648 meters squared. For the northwest, 8,494 meters squared, and for the window area is 4,649 meters squared. Northeast, we assume same with southwest, which is 11,384 for the facade, and for the window area is 3,648. Okay, the formula for OTTV is 15 alpha 1 minus window to wall ratio times with the value of the wall. And the table below, you can see there are the materials that we use to build our wall. So the first one is external surface paint with the thickness of 0.020. The second material is ACP cladding, 10 mm. The third one is cavity. The fourth one is polystyrene board. The fifth, external wall plaster. 6 is brick wall. 7, internal wall plaster. And the last one is internal surface paint. And you can see there are the thermal conductivity of the material. Then we need to calculate the thermal resistance. R equal to M divided by K. M is the thickness of the material and K is the thermal conductivity. And after doing the calculation, the total arc that we got is 1.317. And to find the U, 1 divided by R. And the value of U that we get is 0.76. This is the absorptivity alpha for wall and roof surface. Okay, for this one we choose polished aluminum sheet and the value is 0.2. Okay, after that, after decided our new value and for the solar absorption factor, we calculate the TTV using the formula, and the overall total wall OTTV is 33,583.2. Okay, this is the cross section of our wall material. And then, okay, the next part is heat conduction through windows. This is our table. For this part, we only have to find the U value. We have to decide the U value, and the glazing type that we choose to find the heat conduction through windows is double glaze 1 inch with clear heat film, and the U value is 0.21 to 0.26, and the U value for the calculation is 0.23, and for the total window OTTV that we calculate from the formula, 6 times with window to wall ratio times with the U value UF is 267,054.38. And next we go to solar heat gain through walls. For this part, we have to find the shading coefficient SC equal to shading coefficient 1 times with shading coefficient 2, and SC1 shading coefficient of glazing. For the glazing with U value of 0.23, the solar heat gain coefficient is 0.30. So the next step is we have to find the SC2. Okay, this is how we find the R1, the ratio of shading and the window, x divided by y. You can see the shading is x is equal to 1.23, and the distance between the shading to the lower part of the window is 2.8. Therefore, x divided by y is equal to 0.44. And then we have to look on the table. Based on the table, 0.44 range from 0.3 to 0.4. So you can see there are the value. For the north is 0.77, north and south east 0.77, west 0.79, northeast southeast 0.77, northwest southwest 0.79. And this is the calculation to find the shading coefficient, which is equal to SC1 times SC2. For the southeast, we got 0.23, southwest 0.24, northwest 0.24, and for the northeast is 0.23. And then we put on the table, and the total window OTTV we got is after using the formula given, 194 times with solar correction factor times with window to wall ratio and times with shading coefficient. The value is 874,907.42. Okay, and then the next part is the OTTV of building envelope, the overall OTTV. So you can see the other formula that we use to find the overall OTTV, and after adding all the OTTV for each orientation and adding all the area of the building, the OTTV that we got is 20.3. And the OTTV of the building envelope for a building having a total air conditioned area exceeding 1000 meters squared should not exceed 50 W and meters squared, and should meet the requirements specified in MS 1524 2013 clause 5.4.2. The clause stated that in order to take the advantage of daylight harvesting, the visible light transmission of the daylight fenestration system should not be less than 50%. And this is the RTTV. The last part is RTTV. Okay, you can see there are the material that we use to build our roof. We use steel decking and structure. We use mineral wood bed, plasterboard liner, and the internal surface. You can see the internal surface, external surface. The total arc that we get from this material is 4.259, and U value is 0.235. And this is the cross section of our roof. And okay, I think that's all from me. The next part will be presented by
I'd like to continue about the green parking design. For green parking design, we have two, that is outdoor for the ground floor and the basement parking. For the outdoor parking, it provides solar panel which can charge the electric cars. Besides that, trees around the parking lot supply more oxygen. This figure is shown from the that we have designed for the outdoor parking with the solar panel on the roof based on the green parking concept. So this is the solar panel. This is the electric car charger. And for the basement, this design of basement car parks requires careful attention to ensure that they are safe to use and they do not have a negative impact on the street scene at ground level. In this design, we also provide the solar panel that we place on the top of the roof. The solar panel then can transmit the solar energy to the basement for the electric car charging. So this is the figure that shows the electric car charger.
Now,
That's all
I
from
would
me.
like to continue our presentation about rainwater harvesting system. Water is the one element that very important to our life every day. The lack of water will make a big problem in our daily life process. So our group have reduced this rainwater harvesting system to reduce problem at the building. To reduce the problem at the building about the crisis of water. This is our design, our rain harvesting design at the building. This system will be placed at the top roof of the building so that it efficiently water go through to the system. The advantage of the rainwater harvesting is the water from the system can be used for toilet, car washing, garden watering, and many more. Besides that, this system will reduce the using of clean water, and on that time, the building can save more money to pay the water bill. Our group has considered the average rainwater in Kuala Lumpur because this building located in Kuala Lumpur. Based on this graph, show November is the most rainfall in Kuala Lumpur. So for calculation to design storage tank, we take average rain in Kuala Lumpur in November to calculate the capacity of tank that we can use for this rainwater harvesting. First, the estimation area of the catchment of rainwater, we estimate 100 meter square. Average month that height rainfall 330 millimeter. Estimation of runoff coefficient, that is rainwater run away from the roof, is 0.85. Monthly water harvesting, so monthly water harvesting coefficient is 100 times 0.33 meter times 0.85, so equal to 28.05 meter cubic. So the size of tank must 20% larger than monthly water harvesting potential, is 120 divided by 100 times by 28.05 meter cubic, so equal to 33.66 meter cubic. So that's our volume of tank that we can use for this building. So that's all for
solar power panel. Okay, why we choose solar power? One of renewable energy that most popular at this time. At the same time, it's decreased the bill electric of the building. Totally silent and non-pollution. Require little maintenance and have a long lifetime. Next is how it functions. A larger number of a solar cell will be found in every solar power panel. The energy from the sun will be absorbed by this solar cell. This solar energy derived from the sun will be converted into the electric with the help of a solar power panel. The photovoltaic panel of the solar power plant will convert the solar energy into electric energy. The electricity which is generated to this panel is mostly DC, direct current, which will be converted into the AC, alternate current, with the help of an inverter. This inverter will usually be made available along with the solar power panel. This is our design portion of solar panel. We put the solar panel at the top of the building, where the solar panel locates. That's all from me.
Hello, now I want to proceed our presentation for the lighting system design. We use Dialog Evo 3 software to design the lighting system. This is our building that we use 3 types of lamp to design this lighting system, which is double fluorescent lamp, LED and recessive luminate. At the office section area, we use EFU 110 watt fluorescent double lamp model from Appleton manufacturer. This lamp have two advantage: is explosion proof and dust ignition proof. It is the one for this lamp is 120 volt and its frequency is 60 Hz. We choose fluorescent lamp because this type of lamp is one of the good lighting type. As we know, the office area need a good lighting. So I think by choosing the fluorescent lamp is the best. The other area that we use this type of lamp are the pantry and stair. The total illuminated lux that we get for the one level area is 40,100 LM. This is the area, the lighting for our office. And now we go to the toilet. This is toilet. As we know, a toilet no need brightness. So I think so. For the toilet, we use the ultra rectangular recessive luminate soft light that manufacture from the attack manufacturer. The total illuminated lux that we get from the building is 5,250 LM. Now we go through to the lift area. This is lift area, lobby lift. This area we use axial circular recessive luminaires, down light setting, and anodized aluminium. This is manufactured from ATAP manufacture. For lift area, we no need to brightness because we don't do any work at there. We just use to go to the other side. I think that's all for my presentation. It is what we see from the outside. This is the meeting room. Sorry, but last not least, the color, the paint of the wall is influence the lighting design. That for our this building we use not too dark color. I think that's all for this lighting design. Thank you.
That's all from our group, and thank you.
Clap along if you feel like a room without a roof. Clap along if you feel like happiness is the truth. Clap along if you know what happiness is. You, hey, hey. Clap along if you feel like that's what